Esteemed scholars, welcome back. We want to take real life applications of the indicial equations now. But don't forget to continue to like our videos. Don't forget to continue to share them or repost them. And we would appreciate your subscription to our channel. Let's look at the very first example. Here, we want to solve the equation 2x minus 1 raised to power 3 equal to 125. We want to solve 2x minus 1 raised to power 3 equal to 125. Here's our answer. Here is a typical equation leading to indices. Bracket open, 2x minus 1 raised to power 3 equals to 125. There is a mathematical term on the left, but on the right you have a number. It's possible to rewrite this number 125 as a mathematical term. Why? 125 is a perfect cube. It could be replaced with 5 raised to power 3. And so we do that. That is 2x minus 1 raised to power 3 equal to 5 raised to power 3. Clearly, the powers, the indices are the same. We can therefore equate the bases. So we say equate the basis because the indices are the same, as follows. That will give us 2x minus 1 equal to 5. It's simple arithmetic now. All we need to do is to simplify by collecting like terms. 2x equal to 5 plus 1, giving us 2x equal to 6. X has a coefficient 2. Use it to divide both sides. 2x over 2 is equal to 6 over 2. Therefore, s is equal to 3. So the solution to this indicial equation is x equal to 3. Let's take another example quickly. Example 2, solve 4 raised to power c minus 1 equal to 64. Solve 4 raised to power c minus 1 equal to 64. Look at our answer. 4 raised to power c minus 1 is a mathematical term or character equal to 64. So this equation would have been an indicial equation if 64 were another mathematical term or character. Can we make it another mathematical term or character? Yes. 64 is 8 raised to power 2. That's a mathematical character. But it does not agree with the principle of indicial equations because here the base is 4. We are going to make 64 a mathematical term or character whose base is also 4. That is why we are not using 8 raised to power 2. What then can we use? We can use 4 raised to power 3 because 64 is a perfect cube. That is 4 raised to power c minus 1 is equal to 4 raised to power 3. 4 times 4, 16. 16 times 4, 64. So you notice here now that it is the bases that are equal or the same. We can therefore equate the indices. So we simply write equate the indices because the bases are equal as follows. C minus 1 equal to 3. This is nice, simple equation. So collect like terms to solve it. C will be equal to 3 plus 1. When minus 1 moves over the equality sign, it becomes plus. And 3 plus 1 is 4. Therefore, C is equal to 4 is the solution to this indicial equation. So don't forget, in an indicial equation, you may only have two pairs. One on the left of the equality sign, the other one on the right of the equality sign. In example 2, it is the bases that are equal. So we equated the indices to solve them. In example 1, the indices were the same or equal. So we equated the bases to resolve it. Let us do yet another example quickly. Example 3. What is the value of m in 2m raised to power minus 3 equal to 54? What is the value of m in 2m raised to power minus 3 equal to 54? Here's our answer. 2m raised to power minus 3 equal to 54. The first thing that we're going to do is to divide both sides by this coefficient 2. That will give us 2m raised to power minus 3 over 2 is equal to 54 over 2. That will give us m raised to power minus 3. 54 divided by 2 is 27. This is a mathematical term. All we need to do is to make this side a mathematical term. That will give us m raised to power minus 3 equal to 3 raised to power 3. Because 27 is a perfect cube and it is 3 raised to power 3. Now, let us rewrite m raised to power minus 3 using only positive indices. That will give us 1 over m raised to power 3. And that will equal to 3 raised to power 3. 1 is the same as 1 cube over m cube equal to 3 raised to power 3. Since 1 is carrying cube and m is carrying cube, we can rewrite everything there as bracket open 1 over n bracket raised to power 3 equal to 3 raised to power 3. So here now you notice that the indices are the same, so you can equate the bases. We'll go ahead and do that quickly. So we simply say equate bases because indices are equal as follows. That will give us 1 over m equal to 3. We are looking for m, not 1 over m. So to simplify further, 1 over m is the same as 3 over 1. LCM of 1 and m is m. So multiply here by m and multiply there by m. That will give us m times 1 over m equal to m times 3 over 1. Some of you will usually say cross multiply at this level. The answer will still be the same. It's just that cross multiplication is not mathematical. So m cancels m, leaving us with 1. M divided by 1 is m times 3. That gives us 1 equals to 3m. Divide both sides by 3, the coefficient of m. That gives us 1 over 3 equals to 3m over 3. 1 over 3 will be equal to m. So it therefore means that the solution to that indicial equation is m equals to 1 over 3. Thank you for listening in. If you have questions, don't forget to leave them for us in the comment section. We'll see you in the next videos as we take more examples. Thank you.